Hello. So today I'm gonna be teaching you how to add 2D sprites in a 3D world with rotation. So whether you look at the sprite in front, the back, the left, the right, it's gonna have different sprites that will make it seem like it's a 3D object, but it's just a 2D sprite that's changing sprites like every time you look at it from a different angle. Okay? So I've already added the code here. I'm just gonna add the code in the description or in the comments if someone would like to check. But basically here, this is like the only things that we need here. Sprite renderer, then the sprites that we're gonna use. So sprites that are looking like the front, looking at the back, looking at the upper left, upper right, lower left, then lower right, stuff like that. Basically the eight direction: front, upper right, lower right, back, lower left, left, and upper left. So then the transform camera, we also need reference to the camera so that we know where the player is. By the way, the player would be a first person player, so yeah. Then we can also make the sprites always look at the camera. So because if you don't make it always look at the camera, when you look at the sprite from the side, it's not gonna show, because it's a 2D thing. When you look at it from the left or right, you're not gonna see anything. So we're gonna make it always face the camera. In the start here, in the start, we're gonna set sprite renderer would be equal to this dot game object dot get component sprite render. But you can also add serialized field to this, so you can just put it in the inspector. In here I referenced cam since I only have one camera, which is the main camera. The main camera always has the tag, tag main camera. So the camera with the tag main camera would be the camera dot main dot transform. So in void update, as I said, the sprite always needs to look at the camera, so I added transform dot look at. That's like the no. Then what you're gonna add in the is cam, so it's always gonna look at the camera. Then for the direction, we need a reference to the direction. We need the direction because we need to know where the camera is relative to the sprite. So we need to know whether is the camera in front of us, is the camera behind. So yeah, we need the direction of the camera. And in order to get the direction of everything, direction would be equal to endpoint minus start point. Remember that. So if you need a direction, just remember direction would be equal to endpoint minus start point. So our endpoint here would be the camera dot position, since this script would be attached to the sprite. So our endpoint would be camera dot position, and our start point is transform dot position. The transform dot position would be the transform of the object that is the transform of the object that this script is attached to. Then when we have the direction, we're gonna get the angle so that we can know whether it's in front, behind, left, right, upper left, lower right, something like that. So float angle, we're gonna add a float. It would be float angle, and that angle would be equal to mathf dot tan2. This code, I think, yeah. This code is used for 2D stuff, but we're gonna use it in a 3D world. So usually when you write mathf dot atan2, it's gonna ask for float y and float x. See, it's for a 2D world, but since we're in a 3D world, we're gonna replace y with z. So we're gonna get the direction z and direction dot y and direction dot x, I mean, sorry. Okay, so as I said, we're gonna get the angle by using mathf dot atan2 on the direction that we recently got, and mathf.atan2 returns radians. You don't need to know what radians is, as long as you need to know that when you use mathf.atan2, you always need to add times mathf.radians to degrees at the end. So it's all proper. Then this angle is gonna return a value from 0 to 180. Not 0. Negative 179 to 180. So basically, like it goes from 0 to 180. Then when you increase it, it's not gonna go to 181. It's actually gonna go the opposite way. It's gonna go to from 180 to negative 179. So it won't go further than 180. We have this image here. The numbers here are the possible combinations of the angle that's gonna be returned. So the angle can return 0, 45, 90, 135, 180, anything in between. And from 180, it goes to 135, 90, negative 90, negative 135, negative 45, and back to 0. So we're gonna check, since like it's gonna return numbers, we're gonna check what number it's returning. So if we just like check like is angle equal to 90, it's only gonna change when it's really equal to 90. So in order to like get like a proper, like we can get like the proper we like return the we like check whether like it's just within range of 90 by like checking like is the number greater than 67.5, but is and basically like we're gonna check like is the number greater than 67.5 and is less than 112.5. Then if it's true, we're gonna return 90 and it's in the front. Just think of my mouse as the camera. So if we only like check like is angle equal to 45 or is angle equal to 0, it's not gonna like get anything here. It's only gonna like return true when it's really right in front of the 45. So in order for us to like be able to like move around and still get accurate, like the accurate direction, we're gonna like add like these blue, which is like half of 90 and halfway between 90 and 45, halfway between 135 and 90, halfway between like two of the black lines. So we're gonna check is if the angle is greater than 22.5 and if the angle is greater than 67.5. So yeah, you can see like yeah, it's now less than 67.5 and it's greater than 22.5. So because somewhere here is gonna return like 66, something like that. So it's already looking at the upper right. And here, yeah, here would probably be 15. So is 15 less than 22.5 and is greater than negative 22.5? Yes, so it's gonna return like right. So here, yeah, that's what we did, where we check for the front. For the front, we're checking like front, is it less than 112.5 and is it greater than 67.5? If so, it would be the front. And we're gonna set the sprite render dot sprite to a sprite that's looking at the front. Else, if the angle, we're gonna set the sprite renderer sprite to a sprite that would make it like so that we can see it if we're at the front of the object. Yeah. We're also gonna then we're gonna check like I'm doing this clockwise, so front, upper right, right, lower right. Else, if the angle is like less than 67.5 and it's greater than 22.5, so it's less than 67.5 and greater than 22.5, upper right. less than 22.5 but greater than negative 22.5, right? Great less than negative 22.5 but greater than 67.5, negative 45, so still works. That's basically the same for everything. But since yeah, this changes here, like it like negative 57.5 to 180. Yeah, for the last one, which is the, it's not actually the last one, it's a bit different. This is for the left, which is this, the one like changes sign. uh if if the angle is greater than negative 57.5 and it's greater than 157.5, and there's no number that can be like that here other than 180, so it will return left. So now when we have like all the code that we need here, like the reference for our variables, we already set our variable, we already made the sprite always look at the camera, we got the direction and we turned that direction into an angle so that we can know the like where the camera is. Then we added these if statements with the blue numbers here so that we can precisely know like the location of the camera. So what we're gonna do now is yeah, to add the sprites. So I've already prepared the sprites here in the sprite editor, as you can see. One is looking at the front, one is looking at the upper right, one is looking at the right, looking lower right, looking at the back, looking at the like lower left, looking at the left, and looking at the upper right. So we're gonna name this, like for example, the sprite is S. So looking at the front would be W, looking at the upper right would be E, looking at the right would be D, looking at the lower right would be C, looking at the back would be X, looking at the lower left would be Z, and looking at the left would be A, looking at the upper left would be Q. That's easier for us to add. So we're gonna get this thing here. We're gonna get like the sprite renderer, the object with the sprite render. We're gonna add sprites. So there's 7 sprites in total. 8 sprites. Yeah, 7 sprites in total. I mean, there's 8 sprites. Yeah, there's 8 sprites. Sorry. Yeah, 8. But if we're gonna add it, we're gonna add it in reverse. So front would be back. So X goes first. Then I do it since I did it X, then C, I think. C, D, E. I'm also gonna give like the template for this so that you can create your own sprites. W, Q, A, and Z. If it's wrong, we're just gonna fix it again. Is even though I'm already teaching you how to do it, I'm also a bit confused, but I kind of get how it works. And by teaching, I want to improve on what I know. See? Am I moving? Okay, so we are approaching the sprite now. Oh, the camera isn't like sticking to the player. Okay, my bad. Okay, so yeah, I have a first person controller here. So when we move, I'm just gonna maximize it. As you can see, uh, oh wait, no, yeah, I placed it wrong. No, I placed it, yeah. So we're gonna change it again. What was wrong? We're gonna check while we're not in full screen. This is a very confusing tutorial, but it works. I hope you like get the gist of it. What is it? X. So it's rendering the correct thing. It could also render the correct thing when it's so X and W is correct. Q. Q and E. Yeah. Look, getting better, getting better. D. D and A. D and A is like wrong. So this D is supposed to be A, and A is supposed to be D. Yeah, all better. Then Z and C. Then Z and C is supposed. Yeah, see, all better now. And that's about it. If you want the code, I'll put it in the comment section. And if you want the image to like have like reference for your sprites, I'm gonna also put it in the comments down below. That's about it. Thank you for watching. Thank you for listening. I hope you understood something. If you didn't understand anything, I hope you got the gist of it. I'm not the greatest teacher, but I want to help you.